All right, let's talk about the invisible force that powers pretty much everything in our modern world. We're going to pull back the curtain on something you use every single day but might not think about: alternating current.
I mean, really think about it. You flip a switch and light just happens. You plug in your phone and it starts charging. What is the invisible river flowing through those wires that makes it all possible?
Well, the answer to that question is all around us, hidden right inside the walls of our homes. We're talking about a really cool phenomenon called alternating currents, or as most of us know it, AC. And that right there is the key. You see, unlike a river that just flows in one direction, AC is much more like the tide. The electrical charges move one way for a split second, then they reverse and move the other way, over and over in this constant, super fast rhythm.
So, what does this dance of charges actually look like? Let's zoom in a little closer and really understand what makes AC tick. Now, you're probably most familiar with DC, or direct current. That's the power you get from a battery. Think of it like a one-way street. The electricity flows out, powers your device, and that's it. But AC, the stuff from your wall socket, is completely different. It's that constant back and forth dance. And the speed of that dance has a name: frequency. It's just a way of measuring how many full back and forth cycles happen every single second. And we measure that in a unit called hertz. So, here in India, our power grid runs at 50 hertz. What does that mean in the real world? It means the current in your walls completes 50 of those back and forth cycles every second. And since each cycle has a forward and a backward push, it's actually changing direction 100 times per second. It happens so incredibly fast that for us, it's completely seamless. So this brings up a huge question. If DC is just a simple, straight line of power, why on earth did we build our entire civilization on this more complicated back and forth system? It sounds kind of inefficient, doesn't it? All that changing direction. You'd think a straight shot would be way better. Well, it turns out there's an absolutely genius reason why we do it this way. And the answer is actually really simple. We waste way less energy. You see, if you try to send a lot of power over hundreds of kilometers, you lose a ton of it as heat. It just radiates away into the air. But AC has this amazing trick of its sleeve to solve that problem. And this is the magic right here. It all comes down to a device called a transformer. And this is crucial. Transformers only work with AC. At the power station, they use a step-up transformer to crank the voltage way, way up, which actually lowers the current. This low-current electricity can then fly across the country with almost no energy loss. Then, right near your neighborhood, a step-down transformer safely lowers the voltage back to a usable level before it gets to your house. It is an incredibly clever system. Okay, so we know AC is the champion of efficiency. But how do you even measure a power that's constantly changing? This is where things get a little bit weird, but also really cool. Think about it. If the current is positive for half a cycle, and then equally negative for the other half, what's its mathematical average? It's 0. But obviously the power coming out of your wall isn't 0. It's definitely powering your fan. So what is going on? We've all seen this number on our appliances, right? The standard voltage here is 230 volts. If the average is 0 and the voltage is always in flux, what exactly is this 230 volts that we're all talking about? It's not the average. And as you're about to see, it's not the peak either. The answer is a clever bit of math called the RMS, or root mean square value. Now, don't worry about the name. The easiest way to think of it is as the effective value. It tells you the equivalent DC voltage that would give you the same amount of power. So 230 volts of AC provides the same oomph as 230 volts of steady DC. It's the number that tells us the real, usable power we're getting. And here's the part that just might blow your mind. For us to get that effective 230-volt value, the voltage is actually peaking at a much higher number, around 325 volts. So that current is swinging all the way up to 325 volts, then down to negative 325 volts, 50 times every second to give us the steady power we rely on. So we know what it is, and we know why we use it. But where does AC even come from? For that, we have to take a quick trip to the power station. It all boils down to a beautiful law of physics from Michael Faraday. Basically, inside a giant generator, you have a huge coil of wire that's spinning inside a powerful magnetic field. As that coil rotates, the magnetic force on it is constantly changing, and that change induces an electric current. And because of that constant rotation, the current it creates naturally alternates its direction. It just creates AC by its very design.
And remember that 50 hertz frequency? Well, it's no accident. It's precisely controlled by just two things: how fast that generator is spinning and the number of magnets it has inside. So let's zoom out and put all of these amazing pieces together, from that massive spinning generator all the way to the little light switch on your wall. Isn't that incredible? Every single time you turn on a light, you are tapping into this vast, elegant system. You're connected to the physics of sine waves, the precision of frequency, the cleverness of RMS values, the genius of transformers, and the fundamental laws of our universe. It's an invisible, silent, and powerful network that literally holds our modern world together. It is so much more than just a current. It truly is the foundation of everything we do.